Hello, welcome to another session of the Houdini training. My name is Gianvito Serra and today we're going to be looking at parameters a little bit closer, okay? This is a continuation of the last class, which was related to the nodes themselves. And we're going to take a little bit of a closer look at the parameters that are in the parameter window here and are associated with a node, okay? Okay, so now that we know a little bit more about nodes, let's talk a little bit about parameters. Okay, let me go ahead and start. Oh, actually, we can use this since we actually have the parameter window here. So the parameters are basically variables which tell the node how to operate on their task that they do. Okay, so if we go back to the clip sub and turn it back on, we know that the clip sub is a node which cuts the geometry given a clipping plane, such as this. Okay. Now, the parameters allow me to tell the node specifically how do I want to do this clipping. So instead of, for example, using the default values, which will cut it on the Y and at the origin, maybe I want to cut it a little bit higher or maybe a little bit lower. Maybe I want to cut it at an angle. Okay, parameters on the node simply allow me to specify how do I want this node to operate. Okay. Parameters can be of many different types. We've seen, for example, sliders. We also seen vector fields, which allow me to actually change numbers, as vectors. We also have drop-down menus, which in some cases are strings, some cases are integers. For example, here I can switch in between keeping the primitives over the plane, keeping the primitives below the plane instead, or actually keeping both and just actually having this slice travel to my geometry. Okay. We also have toggles. In this case, for example, I can create groups for the above and below planes, which we'll get into that a bit, how those work. But the idea here is that parameters can come in many different flavors and in many different types. You can even have strings and so on and so forth. Okay. When you click on a node, the parameter window updates to switch the parameter to whatever node you're viewing at the time. Okay, so if we look at the grid here, when I select it, the parameter window shows the grid node that I have selected. Now notice that you can be displaying a node, but actually have the parameters from a different node, and that's okay. Okay, this is very useful. So for example, if I wanted to see the divided version of my node, but I still wanted to be able to control the clip amount, I can see the divide while I'm changing the clip effect. Okay, so very useful for debugging, and also really used for your general workflow inside of Houdini. Okay. We can at any point when you rewire a node. So let me actually bring in a sphere. Okay. And I'm going to switch my sphere from primitive to polygon. When you rewire a node, we can also keep the focus on a particular node and simply just change the node that is being fed in to see a different effect by switching the node. Okay. And just like we showed before, as I change these parameters on the sphere, you will see that the node updates on the fly as expected. Okay. Very cool. Another thing to note about parameters, which is useful, is that you do not have to actually drive parameters using these sliders or these numbers in the UI. Okay. We can actually, for every node that we have, we can select a node, and if we click on the little widget below the scale, it's called a handle. Every node has a manipulator associated with the operation that it does. So in the case of the actual clip node, for example, we can see the actual clip plane We can even use this to move the clip plane around and see the operation of a clip happen as we move this parameter, okay? Can even use, for example, this little widget on the top to move the clip plane dynamically, okay? If we click, for example, if we go, for example, on the actual sphere, you'll notice that, and I'll highlight this guy now, you will notice that I also have a widget here that is associated with the sphere node, which allows me to dynamically scale my sphere using a 3D widget on the screen as opposed to the actual parameters that we see here, okay? So it's a very neat thing because it allows us to do operations which are sensitive to the node that we have, even when we have other nodes that are highlighted. So even if I have a node that is highlighted and I select the sphere, you'll notice that I can still modify the sphere with the 3D widget and everything shows up on the screen, which is great. The transform node, for example, will have an actual widget that is more familiar to people, which is the actual transformation widget, okay? Very cool. Now, parameters in a node are very interesting and powerful thing because in addition to be able to have the parameters work the way they do, and just you type in numbers here to drive how a parameter works, we can do some very sophisticated relationships in between parameters. So for example, if we bring our sphere here again, and I'll keep my focus on the sphere for a little bit. Say for example, I want my sphere to actually be 2 times taller than it is width, or maybe like 1.5 or so, right? Well, this is cool, but if for some reason then I need to make this sphere bigger, say that I wanted to then make this 2, now all of a sudden my proportions are completely off, and this doesn't work for me anymore, okay? So of course, I can go in here and say like, okay, well, I change this radius to 2, that means I need to change this z to 2, and then I need to also change my y size to match this, so it needs to be probably 3 to be back the way it was before, okay? We say the art director came by and said like, you know what, now I want your radius, your width to be 4, and I need you to be the same proportions as it was tall, okay? So this is very typical in productions and can get old quite quickly. So what Houdini offers to you to not have to work this way, and one thing that you can do with parameters is that we can create small expressions which help us drive how parameters relate to each other. So if I want the y-axis right radius to actually match the x radius, we can create a simple expression by right-clicking on a node and saying copy parameter, and then right-clicking on the other node that I want to drive and say paste copy its references, okay? Now watch what happens when I do this. Actually, I'm going to do it again. So I'm going to just show you with the z-axis so that they all match, okay? So I'm going to copy my parameter here. And then I'm going to right-click on here and say paste copied references, okay? Very cool. Now watch what happens now when I change the radius, okay? You will notice that I change the radius in one place, and my sphere stays the proper size. And if I left click on the word radius, you will notice that the expression changes to the actual value that you're getting from the expression. And as I change this number right here, the numbers here automatically change for me. So what's happening here, which is really cool, is that I created a relationship using the CH expression, okay? So if we look a little bit closer to what this expression is doing, okay, and I'm going to actually simplify the expression so that we can see it a little bit better, okay. What I'm doing here is that I'm saying, let me copy the expression on a note. What I'm doing here is saying that the y and z value are going to be equals to the radius of x. Okay? So what happens with that expression now is that as I actually change the radius on x, the y and the z change accordingly. So this is great. You can create these expressions in many ways. You can actually type them in. So say, for example, I delete the channel here and I go back to the relationship being broken. I can come in here and simply type CH, and you will notice that I get a very nifty auto-completion menu here. So I'm going to use, in this particular case, CH. Open parentheses, and I'm going to put rad x. See, it's already showing me what parameters I have available to use. And close parentheses. And now that creates the expression again. Okay? You can also, if you like to do it in a different way, and you can delete these expressions at any point by right-clicking on a parameter and saying delete channel. Okay, I'll show that again. I'll show that again with this actually. Right-click and say delete channel. Okay. Now the expression is broken again. So we can, you can also recreate expressions by simply right-clicking on a parameter and say copy parameters, and then say paste copied relative references. Okay. Now I'll show you the difference between doing that and doing copy parameter and then saying paste copied references instead of relative references. Okay. So they're both the same, and they all output the same value. Okay. But the biggest difference is that, and you will notice this one is a lot shorter than this, is that this one just uses the short name of the parameter. And the reason why is because this parameter, the radius x, is local, is in the same node as the radius y. Okay? Over here, you will notice that I have a full path from all the way from object, geo my name, sphere 1, right here, and then the name of the parameter. Okay? A regular absolute reference, it will always use the full path. A relative reference will always use the shortest possible path to the actual parameter. Okay? You should barely ever want to use absolute references. You should really always make relative references because those will always work a lot better. Okay? We can even, for example, right-click on a node that has an expression such as this, the radius y here, and say copy parameter, and override the one here with the value from radius y. So paste copied relative references. Okay, so now you will see that I have radius x here, which is what I move. Radius y is being driven by radius x. Okay, and radius z is being driven by radius y. Okay, so I'm going to change one. The other changes. The other two change. Okay, very cool. So yeah, always use paste copied relative references. Okay? Now, another thing to note is that you will notice that I'm using words such as rad x and rad y instead of the full word radius. Okay? But why is that? The reason why is because your label name is different than your parameter name. Okay? If we roll over any of these labels, you will notice that there is the name of the parameter or the label center, but then there is parameters which have a shorter name, such as in this case, center is also equals to th, ty, and tc. Okay? This is also very useful because it will even show you a little bit of help about what the parameter does, okay? Which is very nice. If you go to radius, you will notice that the long name of a label is radius, but the parameters names are rad x, rad y, and rad z, which is what we're using here. Okay? So if you're actually writing your expression by hand and you need to know what parameter name is, just roll over the parameter and look for the short name. In this case, the parameter is not uniform scale. The parameter name is actually scale. Okay? Very cool. Now, but I still haven't solved the problem where the art director wants me to have a sphere that is actually taller than it is wider by 1.5. Okay? The neat thing is that expressions can be actually more sophisticated than just a simple parameter reference, okay? So one thing that we can do, for example, is to say that the radius y is going to be equal to radius x times 1.5. Now look what happens. So this is really cool, right? Now if I actually move the radius x, the radius y is always going to be radius x times 1.5. So I don't have to know how to do that multiplication, and Houdini actually does it for me. Another, it is a very simple expression, okay? It's just radius x times, using star, 1.5. And I'll write it here. So you can see that a little bit bigger. Times 1.5. Okay? So what's happening here now is that I can dynamically drive the y parameter relative to the x parameter, which is great. But now say that, for example, I needed this z-axis to actually be half of radius x. Like right now, if you notice that it's actually based on radius y. So obviously we don't want that anymore. So what we're going to do is that we're going to copy parameter from the x, and then say paste copied relative reference here to make it back to match the x. Then I'm going to say that I want that divided by 2, like a fraction. So now what we have now is a egg-like shape, which changes when you change the x parameter. So the x parameter is driving both the x and the y and the z in a different fashion than the x itself. And you can see the values calculated on the fly for us. Very cool. Awesome. And by the way, if you're trying to remember how to use the value ladder, all that you have to do is to hold the middle mouse key, and then you can scroll up and down to see the level of precision you want, and then go left and right to actually change the value. Okay? Now, in addition to multiplying or dividing or adding by a constant number, you can also multiply parameters against other parameters. Okay? Say, for example, I wanted the radius z to actually be the sum of radius x plus radius y. We can actually do that. All that we have to do, instead of doing divide by 2, is say that radius z is equals to ch radius x plus ch rad y. There you go. And now you will notice that the c value is actually driven by the relationship of those two values. Okay? Very cool. In addition to be able to have a node drive its parameters on itself, we can go actually a lot further than that. So say we get to our clip here. We can also, for example, drive the effect of a clip node based on the actual radius of the actual sphere as well. So say, for example, and I'm going to simplify this a little bit by deleting my... Actually, I'm going to simplify this by actually bringing in a box to make this just a little bit easier to see. And feeding that into the clip. Okay, so now if we zoom in, you notice that I have my bots, and I have a bot that is clipped. Okay, I'm going to create vertex normal so that we can see it a little bit more clear, and my clip work as expected. Okay, now obviously if I change the bot's size, you notice that the clip is a relative position, therefore it always changes relative to the actual size of the bot. Okay, if you look at the clip, it's already using a distance parameter to actually drive where the clip happens. Okay, interesting enough, As I move the bots up and down, though, you will notice that the clip actually swims with the bots because the bots is going up and down. So say, for example, I wanted the clip to actually follow the bots, okay? You can create expressions which are actually drive parameters from one node, that drive parameters from one node, the parameters from one node drive parameters from another node, okay? You can do that by in a very similar way how we have been doing it so far. So let's go back to our bots and select it and say that I want the center of a bot to drive the origin of the clip. Okay, so if we move the actual clip, we can actually move it in different locations, okay? What we can do is simply come here and say, right click on the label that says center and say copy parameter. Go to the clip node and go right click on the origin of the clip node and say paste copied relative references, okay? And the nice thing about that is that is going to create a reference for all of the parameters of a bot based on the X, the Y, and the C correspondent, okay? So the X drives the X, the Y drives the Y, the C drives the C, okay? So now if we go back to the bots and we change the center of a bot, you will notice that now the clip doesn't swim, it actually travels with the bot, okay? And the values match in between the two. This is great, but let's take a quick closer look of what is happening here. If we look at my expression here, you will notice that my expression looks just a little bit different, okay? Where I have a not a ch expression like I did before, but this time I have dot dot backslash bots1 dot and then th, right? So if we look at the bots, the parameter that I'm looking for is called th, ty, and tc, okay? But because I'm in a different node, the first thing that I have to do is that I have to go out of this node into the network by doing dot dot. Then when I'm here, I'm looking for a node called bots1, which is why you have bots1 here. And then in there, looking for a parameter called tz, which is what I have here. Okay, this allows me to create expressions which can go in between multiple nodes, okay? My other parameters still work. This one is just being driven by the location of a bot, okay? We can even allow it to swim a little bit by multiplying this by, say, for example, 1.25, okay? And now watch, as I actually move the bots on the Y, you will notice that the clip node actually swims just a little bit as I'm moving up and down, okay? Very cool. Now, in addition to also drive things using the one parameter to another parameter, there is a lot of other expressions that we can use, okay? So, for example, we can say that we want the clip origin to actually be driven by this sphere right here, okay? And I'm going to come here and go ahead and delete my sphere parameter, my sphere expressions, okay? So I'm going to click on the sphere, and I'm going to go to the radius, which has this expression, and right click on it and say delete channels, okay? So that should give me these explicit values, but then I'm going to right click on it again, and I'm going to say revert to defaults, which gives me a default sphere again, okay? And I'm going to move the center of the sphere to the right. Whoops, I'm going to move this to the right, okay? So that we can see this a little better. Now what I want to do is I want the position on the Y of the sphere now to drive the origin of the location of the actual clip, okay? There's a lot of ways that we can go about doing this, but I want to show you a different expression that you can use to do this, okay? So one expression that you can use is the actual centroid expression. So let's go ahead and delete this so that we go back to the default location of the clip. So right click and say delete channels, and then right click again and say revert to defaults, okay? So we have the default cut of the clip again, okay? Now, say for example, I don't want it to go based on the location of the actual sphere. I don't want to make it based on the parameter. Say I wanted to make it so that it follows the center of the geometry of the sphere, so that if I turn my sphere into an egg, I can still be able to have the clip follow the center of that. So another example expression that you can use here is on the Y. You can click on this and type the word centroid, as in centroid. Give it the path to the sphere. So in this case, we need to go out one level, dot dot, / and then do sphere 1. Okay, and you will see that we get the auto completion. So I'm looking for that node, the sphere 1, and then I'm going to use the word d_y, which is a variable that tells you that look at the center y of the sphere. Okay. Now what happens is that if I move the sphere, you will notice that a clip now follows the sphere center. Okay. What's really cool now is that even if I actually change the radius on the y, you will notice that, well, actually this won't work this way, but if I actually put a transform node or even an edit node, and I use the edit node, the edit state, to modify points on my sphere, you will notice that, oh, I need to also change this to the edit. Let me do that. Create one. Oh, edit, there we go. You will notice that now the clip follows not the sphere where the sphere is located, but follows the center of the sphere geometry. So wherever the center of the geometry is, that's where the clip operates on. Okay? I can still go back and move my sphere into different locations, and that will follow. Very cool. We can also, if we want, for example, let me just go back here to my bots, and go to polygon mesh, and you notice that I have axis divisions. Okay. Say for example, I wanted my axis divisions on the edge to be equals to the sphere's frequency, or actually to the sphere's number of points. Okay. So we can do that by simply saying that I want my axis divisions to be the number of points, and then go back one level and go into sphere 1, and there we go. Now the number of points of my sphere are driving the number of divisions on the edge. That's maybe a little too many, so I'm going to maybe multiply by 0.5. Okay, so I get, actually maybe we'll multiply by 0.1, so I get a little bit less. But you will notice that as I actually increase the frequency of my sphere, or my poly count on my sphere, that drives also the poly count of the actual bots. Okay? Very cool. Also, one last thing that I will show here is that nodes also in many cases have variables which you can access. Okay, so if we press tab here and put a transform node, I will demonstrate that. I'm going to take the template of a sphere and just show this. So if we want to, we can also we can do things, for example, like scale these bots, okay, by just playing with the uniform scale, for example. But say, for example, I wanted the pivot of the bots to actually have the scale of the bots to actually happen at the bottom of the actual bots and not at the center, okay? One variable that you can access on the transform operator is $ymin. Okay, and you can see that I get a little auto-completion there. As you're actually typing these things, you generally will get an auto-completion which will tell you things that you can actually use. In this case, I'm going to use ymin. Okay? When I use ymin, you will notice that now this automatically matches the location of this will automatically match the minimum location of a bot, so that when I scale, I am now scaling from pivoting from the bottom of a bot, as opposed to what it does by default, which is pivoting from the actual center of a bot. Okay? If you click on the help of any node, which will bring the help browser, you can always look for local variables here, and it will tell you what variables you have available on each node to use for your operations. Okay? In this case, for example, we can even use the centroid without using a centroid expression. We can use $z, x, y, z. We can get the x, the y, and the z min match. And we can even use the size of the actual object. Okay? Very cool. Okay. Also, if we go to the help and go to content, we can go to the very bottom and go to the reference section and go to expression functions to see a list of expression functions that we can use through any of the nodes. Okay, so for example, here is if we look a little bit here, you will notice that I have centroid, which is the one that I show you how to use, an explanation of how to use it. Okay, and even some related ones that you can look at. So like, for example, the bbots expression, which does something like centroid, would allow you to get the x mean, the y mean, the z mean, the z max, etc., etc. Okay, very cool. All right, I think this is probably sufficient for today. Like I mentioned before, my name is Gianvito Serra, and thank you for watching.